This lesson will cover guided auto picking. Another lesson I covered simple auto picking, which looks at the whole trace and tries to find the best event based on this Copin's picker, which is a sliding two windows, a ratio of two windows sliding up and down the trace, and trying to find where the first event of any of consequence occurs, a peak or a trough, whichever we're trying to measure. In this one, I'm going to talk about guided auto picking. And guided auto picking, as the name implies, is a way for us to tell the program the vicinity in which to find the pick. So the auto picking will be confined to a very limited zone on the trace. And in noisy data, this will probably make a huge difference in how successful this auto picking is. So anyway, let me just show you on this data set. The regular auto picking works fine in here in this case, but the guided auto picking actually works a little bit better. So here we are, I have a pick window up, and as you can see, right now I'm just, let me turn on the window here. As you can see, I'm looking at a single receiver line for any particular shot that I happen to click on on the map here. So first thing we're going to do is I'm going to look at all the traces. I'm going to turn the grouping off, so now I'm looking at all my traces, and I have 6 receiver lines, as you can see here. And let me go to this here, where is it? I'm going to display a background color, and I have the receiver. I'm doing it by, this is by receiver lines, as you can see, so I'm coloring my receiver lines. Not for any particular reason, just so you can keep oriented. So I have 6 receiver lines here. And the first thing you have to do with guided auto picking is, as the name implies, provide a guide. Okay, so the guide we find under picking, you'll see this thing called delay define linear move out trend using traces. This linear move out trend is going to be the guide that we're going to use for the auto picking. Now on this display here, you see a grid map here, and you see these pink dots. These pink dots are those sparse CMP gathers that, if you recall, when we built the project, we said yes, we would like sparse CMP gathers. And these are what I have is a selective of traces ordered by CMP at each one of these points. And as you can see, it's very fast. Now, right now I'm using those CMP gathers. If I wanted to click someplace in between, like let's say I have a big survey and a very, very sparse CMP gathers, and I wanted to click someplace in between, I'd have to turn that off, just temporarily perhaps, just to get to places outside of those these sparse CMPs. Because right now, if I click here, for example, it's going to take me to the closest one. Okay, so here's my gather here. I prefer to do this using LMO. So I'm going to apply linear move out. I'm going to lock the time axis to be, say, 0 to 300, and maybe minus 100 just to center it a bit. Click enter, and now I'm going to provide my guide. And I'm picking this trough, as I mentioned in earlier, and I prefer the trough in this particular data set. And now I'm going to click over here, do the same thing. And I prefer to start off, as you can see here, I've started here when there's no traces, because if I just went from here to here and another gather has traces in here, it would interpolate from 0. So I'm projecting back to about 30 milliseconds here. That's just my personal style. Let's look here. As you can see, it's now starting to interpolate the guide function. And now I'll click over here. And I'm pretty close. The question is, where do I go from this event down to this event? I think I'll go from here. So the northeast section of this survey is the most difficult. And now let's click here. Not bad. So it's interpolated pretty nicely through here. Actually, let me go even better. I'm going to go like this. I'll go just a little deeper. And then let's look around the edge. That looks okay. That looks okay. Looks okay. So our guided, this one here I could probably deepen a little bit. And let's look here. Put a little shallower perhaps through here. Good enough. Good enough. Okay, so now I have a guide function. I'm going to apply the changes. And now I'm going to, here, I'm going to, instead of applying linear move out, I'm going to delete that, and I'm going to apply, on my shift here, move out, apply, move out trend. So now I'm applying that more complex function. And as you recall, the trough is what I picked. So if I did a perfect job on that trough, this would line exactly up on 0. Let's bounce around and see how we're doing. Well, that's a fairly complicated shot. As you can see, I'm not doing very well in the inner offsets here, but this event here is pretty much what I've chosen there. Let's look at here. Very good. Very good. Very good. Well, good over here. And over here, not bad. I could probably do better there. And not bad there. Okay, so anyway, the auto picker is going to center on 0. Okay, so this is the function that we're applying. So now we're going to, we have a thing called an operation here. Let me see, the defaults is called apply options for auto picking. And it's already, so it's applied to move out trend. Let me kill everything here and I'll do that again. Defaults, auto picking, so you can see it's applied to move out trend, Butterworth, filter, and now it's doing a threshold picker. And I'm going to correct this a little bit better. Again, I like 0.2 or so, even when I have guided picking. And I'm going to turn off the grouping. Now let's go around the survey and see how we're doing. Not bad. The problem is up here. As you can see, it's fairly complicated, and let's look at our function again here. And then we have, let's see, what other features do we have here? Okay, so here we have we can apply a maximum error. So let's put 50 on here. So this is around that threshold. So you can see, in this case, for example, it killed this pick. Let me turn that off and you'll see. Okay, so what it's saying is the center of the guided function is right here on 0. And by saying plus or minus 50 milliseconds, I'm going to crop out some of these. You don't want to be too tight, but let's say we get rid of the big ones. And then we also have a thing called minimize trace-to-trace deviations. And what that does is it tries to come in here and find some outliers. And so let's go here and bounce around and again and see what we're doing. See, now these are not mispicks really. These are, this is probably close to the function. If we can let's orient these by offset. Let's change this axis here to be offset, trace offset. So under here, under horizontal axis, I'm going to select it by offset. So you can see here we have this, we're an echelon here. And this guy here is pretty close to the picking because of our threshold. It picked probably close in here on some of these traces, and then decided because of our threshold search upwards, it jumped up to there. So there's going to be some mispicks, or there's going to be some misinterpretation, perhaps, of what's the first break and not. But for the most part, we're doing pretty well here. Again, let's bounce around. Okay, so 0 offsets here, and about 6,000 feet out here, or about 2,000 meters. So right now, I'd say we're doing pretty well. So we go back over to here, we go back to main, we say start batch picker, and let it run. And if you recall the last video on just straightforward auto picking, the program's going to give us an option here to copy these auto picks into the user picks. And again, the default is overwrite valid picks. I've already wiped out all my user valid picks, so I don't have anything to worry about. But if you had been picking a lot of shots prior to this operation, in other words, you've been picking for a day or two, picked several thousand shots on a big 3D, you don't want to overwrite those picks. because what this means is this is going to take any of the user picks that you have, and this is going to write the auto picks onto those, overwriting your picks. So you can choose to overwrite or not right here. So I'm going to copy the column. Is it okay? Say close this, and the program's offering to let us go right into refractory analysis using branch assignment and all that, but we're not going to do that right now. You can see it's now has red picks. The red picks were my user picks, but I still actually have my green picks there. So if I move some picks down here, you can see that I have, these are the auto picks. Now these auto picks are actually from this this particular process here, and these are transient picks. These do not exist. When I go to the next shot, these picks would disappear. So these are not the auto picks that we just did with our batch picker down here. These are the transient picks that I'm running in here in this particular process flow. So I'm going to kill that process, and you can see now my green picks have gone away. Let me move my red picks back up again, and then let's get rid of the axis here and go back to my original sorting, and let's go back to the map, click around. Got a few mispicks here and there. We can choose to clean them up. I don't know, this is not a mispick, this is actually picking on a shallower leg, which may or may not be the event you want, but the program's decided based on this criteria that that's what it wanted. And so like I said, some of these places are somewhat complicated, so it's a matter of interpretation. This one here is almost certainly a mispick. You see one like that. But this guided auto picking is a very, very powerful process for picking large parts of large surveys. Or you can actually limit it by picking polygon to pick only a part of the survey. But I'll go into that some other lesson. Okay, and that's the end of that. And thank you for your attention. Bye.